My name's Chase Bernard. I'm the planning manager for GIS and analytics for the town of Chapel Hill. I'm excited to be moderating this session. Since the last conference, I've been relocated. My GIS function has been relocated from our IT department to our planning department. So when I saw this session was available for moderating, I thought that would be a perfect fit for me. I do have a master's in planning, but I'm not a regular practicing planner, but certainly have interest and excited about all the issues and the three presentations that we have for you guys today. So let's go ahead and get started. We have a discrepancy between what's on the poster outside and what's on the app. So I'm going to go with the app in terms of our order of program because I think most people are probably using that. First off, we have Ben Bearden. And a brief bio on him. After graduating with a master's in city and regional planning from UNC Chapel Hill in 2003, Ben joined the Triangle J Council of Governments, serving as a primary GIS analyst ever since. He's worked on a variety of different regional planning projects over the years, from watershed planning and resource conservation to regional transit and affordable housing projects. Ben is currently managing the Connect 2045 scenario planning model and learning fascinating new things every day. All right, Ben.
Okay, so I'm going to talk a little bit today about this project that's been controlling my life for the past couple of years called the Connect 2045. It's an extension of or it's a second iteration of the Imagine 2040 project, which started back in 2010. And what I'm going to do, I'm going to try to blow through a lot of information really quickly, and I think we're going to have time for questions afterwards. I find that I can talk about a specific subject of any part of this model or analysis ad nauseum, so I'm just going to try to hit on all the main points, and then I'll gladly go into more depth with people afterwards or during the session. Okay, so we'll start with scenario planning and what that is. So what is it? Why is it used? What is it used for? It's essentially trying to figure out what will happen given a different. It's the region's future, looking at different trade-offs between growth scenarios and policy decisions. So Imagine 2040 and Connect 2045 both use this concept of scenario planning to inform the DCHC and Campo joint long-range transportation plans. I believe previously, and then the result of these transportation plans is really to inform which transportation projects get funded. So previously, I think the method was gather a bunch of planners in a room and try to do a best guess of as far as where growth is going to happen, where jobs and population is going to go. Obviously, when you get into more guesswork, there's a lot of room for error. And so this is really a way to create a uniform, transparent, and a reasonable way to determine where these jobs and employment and population are going to go. So this is a really bad graphic that you probably can't see that basically explains that what comes out of the TJ-Cog model is the socioeconomic data, particularly single-family dwelling units, multifamily dwelling units, and then 5 employment classifications. And those are the 5 employment classifications that are used in the TRM. I'll talk a little bit more about them as we get on. But then the Campo takes that and puts that in their regional transportation model and comes up with all kinds of great predictions about what type of development and where it's going to occur and what the transportation demand of those developments are going to be. So we do this using CommunityViz software. Has anybody familiar with CommunityViz? Use it? Okay, great, awesome. So for those that don't know, we don't use its full capability, but it has some really great features that allow us to do these scenario planning projections. So The big thing that it uses is the dynamic attributes. And these are attributes that are essentially formulas that are coded into the attribute table that cause the values to update based on inputs from other parts of the model. So you change density, and it runs through the model and can calculate, what effect that has on future land use and that kind of thing. So it also includes tools for performing two of the big functions of this, which is the land use analysis and allocation growth. So I'll just show some examples of the software itself. Probably can't see it that well, but this is what the interface looks like when you want to put in put in a formula into a dynamic attribute. Basically, you click on the edit attribute properties, the little window pops up, and then you can edit the formula. I believe this is a custom script. No, this is their it's CommunityViz a language that they're using. I believe it's specific to that, but you can also do custom scripts with Python and I believe VBA and some other scripting languages. I just use their interface because it's easy. They make it super easy to use. Indicators are the things that come out. These are the performance measures. In our case, or these are the measures of what the inputs are going to give. So for our case, it's going to be those dwelling units and the residential and employment measures based on the inputs. And all this is done using external lookup tables, which I have an example of here. But basically what the formulas can do is they go and they look at these lookup tables. They look at what the land use type is for the build-out capacity. And based on that land use type, it has a whole set of factors, really density and FAR being the big ones. Density is households, applies to residential density. And then FAR is used to determine, it's called floor area ratio, and that's the area of commercial development with respect to the parcel. And so CommunityViz goes in, sees what land use types or place types they are, and looks at all those variables and uses those to calculate what the capacity is for that parcel. Okay, so I'll get into the model a little bit, and then I promise I'll have some nice graphics here in just a second. So it's a two-tier modeling platform. Basically, what we do is we take parcel capacity for it's a 10-county region, somewhere like 665,000 parcels. That's why we got to break it down into 16 subregions, because that's just way too much for at least our local government computers to handle. So what we do is break it up into the 16 subregions, figure out the capacity for each of those subregions, and that's the total capacity for what can go onto that parcel between now and 2045, because we're looking out 30 years. Actually, that's actually the entire build-out capacity. So no matter what all could possibly go in there, based on the land use, local land use codes and local comprehensive plans. So yeah, the variables and values are used in the calculations. Okay, we talked about lookup tables. Okay, so then the capacities, so we determine the capacity for these 16 subregion models. Then we have to transfer it to what we call an analysis grid, which is actually a vector grid. We're not using raster-based, but it's essentially features that are all uniform squares. The reason we do that is because we need to get all those capacities into this analysis grid to run the final analysis. The main reason we transfer those is because there's only 100,000 grid cells versus the 665,000 parcels. So it makes that a whole lot easier to manage. All right, so finally we get some maps. Here's the subregions. This is the Triangle Regional Model Study Area. Again, 10 counties, 3 of which, Orange, Durham, Wake, are completely within, and then collar counties like Person, Granville, Franklin, Nash, Johnston, Harnett, and Chatham. Yeah, I think that's all. So these are the subregions. They don't necessarily follow county lines, but these were, when they were going around in Imagine 2040, they set up a lot of workshops with local planners, and they kind of determined how these subregions should be split up. And it makes it manageable. I mean, they're not equal. They attempt to have somewhat equal amounts of parcels, but in some cases, it's just, they're vastly different. So, that being said, what you're seeing here, the yellow is the parcels. This is downtown Raleigh. We've got Red Hat Amphitheater here, and then you're over here. So the yellow lines are the parcels, and that's what we get the capacities for. Those capacities get transferred to the grid using an overlap sum function. Basically, it goes in and sees what the capacities are within that grid cell, and then adds it all to that one grid cell. And then that grid cell is the total capacity that anything, residential or non-residential development, how much of that can actually go into the grid cell. So as you can see, the parcels are a lot smaller, the grid cell is a little bit bigger, and then the orange lines are what we eventually want to get to. Those are the TAZs, the Transportation Analysis Zones, that they're used in the Transportation Regional Model. TAZs are bigger than those, than the grid cells. I want to say the grid cells are like 10 acres. But so at the TAZ level, this is a good enough resolution for what we're trying to do. All right, I'm going to run through the model components. There's 3 main ones: the build-out analysis, the land suitability analysis, and then the allocation, which uses the land suitability analysis and the build-out potential to determine where the jobs are going to go. So start with the build-out potential analysis. You have the 3 big things are place type, development status, and development constraints. These all affect how much capacity a parcel can get. The development constraint are areas, environmental or policy-wise, that can't be developed. So wetlands, stream buffers, protected open space, and water bodies. So those are taken out first. And then the parcel place types, we actually do place types are assigned to every single parcel that we get. We work with the local planners. This is where a lot of the collaboration comes in. In a regional project of this size, you have to have really good relationships with your local planners. And a lot of times you just have to do a one-on-one. Some of our partners that have worked on this are pretty quick. They know it to update. Others, it just gets a little trickier because you are trying to make a uniform assessment of a whole region based on, in every jurisdiction. I think we have like 45 or so jurisdictions. Everybody has somewhat different ways that they do their zoning and what those zoning categories imply. So what the place types do is try to create a uniform land use to help determine how much capacity that parcel can get. And then the third part is the development status. So we do parcel place types for every parcel, and we do development status for every parcel. But the development status ultimately will determine whether or not a parcel can accept development. If it's already developed, there's no plans to redevelop it, that's not going to get any capacity. This is important to remember because we're actually looking at how much will happen between now and 30 years from now. We're not looking at what currently exists. We use the 2013 ACS data to make that determination. And then we use the projections to do the rest. There's a couple other things that I'll get to, caveats to that, but in general, that's kind of how it works. So here's a map of our development constraints for the region. Like I said, the wetlands, conservation lands, stream buffer requirements, and water bodies are all shown there. And here is our map of place types. We have, I think, 30 place types, all kind of grouped into these different categories. The rural, suburban, city and town, and special and industrial. Those big categories have each one of those place types corresponds to this. Put a little table, a little example of the lookup table. Each one of those place types has a code. The model goes in, looks at the code, and helps determine what the capacity for that parcel is going to be. Here is a map of what this is kind of the developed versus can be developed. So the dark gray are areas that, for whatever reason, either they're developed or they're green space, or for whatever reason they cannot be developed, or there's no intention to develop them between now and 2045. So those are off limits, and all the white areas are considered areas that can be developed. So you can see a lot of gray on there, a lot of developed areas, especially in the cities, Raleigh and Durham. And then you can also see kind of Lake Jordan, right here. So while that's not, it's not a developed, the model has to treat it as developed, i.e. can't accept any more development. And so this is what it looks like after I've whited out all the areas that can't be developed. Whatever is on there now are the place types that can be developed. You see a lot of green, which is the farms and forest, and the kind of the more rural areas. You see a lot of residential, which is more the yellow areas. You see a lot of commercial and RTP right here, because they have a lot of plans for a lot of redevelopment there. So that kind of gives you a picture of these are the areas where development can go. All the whited out areas we don't anticipate any development to be assigned there. So kind of talked about the graduated grid cell. We use that as the common geography across the whole region. It uses the overlap sum function to get all those parcel capacities out of the parcels. And then there are some variations in the size of the grid cells. There are some larger cells in areas, in very rural areas and places like Lake Jordan, where we know that there's not going to be development. Just to reduce the number of cells for the model to run through, we make a few areas that have a little bit larger cells. But for the most part, they're those standard, like an 1/8 mile by 1/8 mile cell. And then converts about 665,000 parcels to about 105 grid cell features. Okay, and so this is what we get out of after you transfer all that to the grid cells. What you're looking at now is the total capacity of areas after we run it through the capacity model, taking out the areas for that are already developed. The blue, I'm showing capacity of total dwelling units. So in the darker blue areas, those have a lot more capacity. Might not be that attractive, but they've got capacity for growth. And especially in like Johnston County, they have a lot of capacity down there based on and that's, probably makes sense because that's where a lot of growth is going to likely occur, south of Raleigh. And then this is the distribution of the employment potential. It's a lot more clustered. There's RTP, there's downtown Raleigh, there's US 1 corridor right here, in Mebane, there's a little corridor. But so these areas have more capacity to accept total employment. All right. So moving on to the land suitability analysis. Most people are probably familiar with the concept of a land suitability analysis. You're using it to identify locations attractive for growth based on features, other layers that we call the land suitability factors. Connect 2045, we use 15 different factors, and each factor has a unique feature layer. Imagine 2040 used 20. We decided to reduce the amount because the allocations allocations were a lot more broad spread, and so we wanted to give more weight to specific factors. But so what ends up being is a lot more. The land suitability factors can have a lot more effect on where the development goes. So each grid scale is going to get a score based on the suitability analysis, and we normalize that between 0 and 100, and then you rank each grid cell based on those. Here's just a list of the Imagine 2040 variables. There are quite a few. I'll show you and this is the Connect 2045. This is what we're using currently. So in Imagine 2040, a lot of these areas were we used a lot higher results or a lot higher scores, and it kind of evened out the spread. It wasn't. When you have more things that are attractive, it kind of spreads the attractiveness out, and so we wanted to restrict that a little bit so that we'd have a little bit more contrast. So we reduced some of the highway things down, and these are kind of we had mini group meetings with a lot of local planners and our work group to kind of figure out the importance of these. We also had meetings with there was one with the business groups in the triangle, and so these are what we ended up with as our factors. And they involved highway systems, so current and future major roads, interchanges and major intersections, development activity centers, your metropolitan CBDs, which are just Raleigh and Durham. Then the town center and regional town centers are smaller town CDBs. Regional community activity centers are areas in various comprehensive plans that are targeted for where the locals want the growth to go. Transit system, this is based on anticipated light rail and possible CRT in the area, or commuter rail in the area. But what they call them is high transit infrastructure and low transit infrastructure. High transit just means more frequent, is my understanding. And then environmental features, we do 100-year floodplains and voluntary ag districts. We treat these as a negative, so these get a negative score because there's some kind of, you can still build there, but there's some kind of impedance that makes it not attractive. So for voluntary ag districts, there's another tax level that makes it a lot harder, or it makes it more difficult to develop that. You certainly can, but it's not as attractive because you have to pay some more stuff, possibly. And then the last is emerging growth areas. These are kind of ETJs and other areas identified by the locals as emerging areas for growth. And then public sewer areas, which is another big factor. If you can get sewer out there, it's very attractive to development. So I'll just run through the maps really quickly. This is the transit system, so high transit and low transit, and then our high frequency bus corridors. The idea is that areas closer to the high frequency bus corridors will be more attractive to development. And then areas that are actually within the area of influence of those stations, they're pretty small right now, but we use those are considered an overlap. So it gets a score if it's in or out. With the bus corridors, it's a proximity. So it's based on how far it is away from that, all the way out to the end of the model area. Here's the development activity centers. These are proximity based, so closer to the development center gets a higher score. Similar thing with this is the existing and future highways and also anticipated major intersections and interchange locations in 2045, which are also include stuff that's there today because it'll probably be there in the future. Here are the environmental features. Again, these are the negatives, just showing the floodplains and voluntary ag districts. This is the utility and service area footprint. Probably one of the more difficult things to track down. You're dealing with a lot of different jurisdictions with various various levels of quality of data. So some of these really easy, straightforward to get. Others require calls to local utility areas and to try and nail down what they expect, where they expect sewer to be in 2045. And this is what happens to the grids when you throw all this into the suitability analysis and you get a final score. You can see these little dots right here. These are the transit stops. You can see that they pop out quite a bit. A lot of this is being contributed by sewer area, and you can see down here. These are. It makes sense. When you look at it, you kind of make sense. Okay, these seem like areas that are going to be attractive for growth. And of course, we'll send this out and review it. We literally just finished the running community plans scenario last week, so I'm still kind of going through and figuring out the best ways to or get feedback from folks as far as whether or not this makes sense. And the final thing is allocation. And this essentially, we take everything and bring it together in this wonderful Allocator 5 tool that's in CommunityViz now. So it takes the analysis layer, it uses the suitability scores, which are in the grid, and then it uses the capacity, which is also in the grid, and then brings those together in addition to guide totals. This is also a pretty crucial part of it. The guide totals determine how much development is going to happen in a county. These are based on state demographers' office predictions, where we could get them out to, and we do need to go out 30 years, and I think they only go out 20. So we use their methodology to grow those numbers out. And what that does is say, okay, in Orange County, for example, you're going to have this amount of population and this amount of jobs based on current trends and all that. Keep that set, and then what Allocator does is take that total and figures out where in the county it places. There is a hard boundary at the county. It's a decision that was made because the counties are really the units where we can get this kind of information from currently. That's as far as it's from the state. People generally, it's fairly consistent, so that's what we use. And so, the land suitability analysis takes those control numbers and places them, helps determine where, and also with the capacity, helps determine where those jobs can go. The one little caveat, we do this thing called committed development. And what we end up doing is there's a little 3-year gap between 2013 and 2015 where large developments might have gone into the ground. What we want to do is get the exact number of things that have gone in there. And we hard code that number into the grid cell. And then we subtract out the growth total from the control totals. So this is really just a way to say, for locals to say, look, we know that your model isn't putting stuff in this one area, but we know, we're building something right there. We know this is going to be there. So we want to make sure that we include as much of that as we can. Okay, here's a little list of the guide totals. Kind of shows you the maximum amount of these things maximum amount of dwelling units and employees by employment category in each county. There's also a little randomness formula that we've been using very quickly. What this does is it provides a little bit of adjustment to the suitability score to alter how much of attractiveness that can have on development. We do this because a lot of times things don't develop according to how we have them laid out in the model, and sometimes, a parcel just across the street from a current parcel might be more attractive. So we use this as kind of a way to randomize a little bit. I think it's only going to adjust the values by 1 or 2 points, but it adds a little bit of randomness in there. And so, final results from the most recent run. This is showing where we expect the dwelling unit. This is households, total households in the region to show or to develop. A lot of area down here. I know there's a lot of growth going on in southeastern Wake. Garner and Clayton, those areas, and also over west of Raleigh, east of Raleigh. So that kind of gives you an idea of what the model is saying. This is where in 2045 households are going to go. And a little more clustered on the employment side, but still same idea. In 2045, this is where we expect the bulk of the jobs to be going. Okay, so now questions. If I've got,
I think
you want to
we'll
wait till the
end, and we'll have some
Sounds good.
questions. So, thank you, Ben.